Hello everyone, so welcome back to my channel, and today we having week 11 assignment 11. And in this video I give you the whole solutions, and in this questions are so long, so I just give you direct solution without reading whole and just having key observation in this. So for that, the first question is Chinchilla scaling law revised at the Kaplan it recommendation for compute optimal training. Which of the following best captures the core empirical finding and its implications for training budget allocation? So the uh first one solution is B. The optimal training token count should scale roughly equally with the model parameters. Kaplan et al. Underestimated the importance of data, causing prior models to be parameterized and undertrained. So the answer is B. Then in the Kaplan et al. 2020, the power law formulation of language model laws. Which of the following statements about the compute efficiency frontier is most accurate? So the answer is B. Kaplan et al. Found the model size n should be scaled faster than the data. Then Kaplan et al. Found the model size n should be scaled faster than data d. Doubling the compute optimal model size requires less than doubling the dataset. So the answer is B. Then Kaplan et al. 2020 model the language model laws under a fixed compute budget C equals to 6 and D, where n is the number of parameters and D is the number of training tokens. So the answer will be C1, this one, and just take the C1. The mixture of experts, LLMs like Mixtral 8 into 7B uses a sparse get-in mechanism. What is the primary technical challenge that sparse MOE introduced compared to the dense transformers during distributed training, and how is it typically addressed? So the answer is B. Load imbalance across experts, some experts becoming overloaded while others are underutilized, cause training instability and inefficiency addressed by auxiliary load balancing loss terms. So the answer is B. Then grouped query attention GQA is used as LLMA2 20B, 70B, and Mistral 7B occupies an architectural position between multi-head attention MHA and the multi-query attention MQA. Which statement best describes GQA design, rational and key trade-off? So the answer is GQA partitions query heads into groups that shares a single KV head per group, reducing KV cache memory and bandwidth pressure while largely preserving model quality relative to MQA. So the answer is B. Then sixth one, rotary position embedding. So through rotation query and key vectors, which property of ROPE is most directly responsible for its long strength generalization capability relative to learned absolute position embedding? So the answer is the dot product of ROPE rotated queries and key depends only on the relative position offsets, not an absolute positions, independently making the attention score function of relative distance. So the answer is B. Then come to the seventh one. Attention with linear biases. Press at L 2021 proposes an alternative to learned or ROPE based positional encodings, which accurately describes the ALA mechanism, which known limitation compared to ROP. So the answer is B. ALBI adds static non-learned linear penalty proportional to the key query distance to attention logis. Before softmax, a limitation is weaker performance on task requiring precise absolute positional reasoning. So the answer is B. Then ninth one. Don't think that every question having answer B, but generally from this I found out that so many questions having option B, but these are correct. So just take the B. And now the eighth one, ring attention enables training transformers on sequence longer that can fit on a single device. What is the fundamental mechanism and communication primitive that ring attention relies on? So ring attention shared the sequence across device, so each device holds a chunk of QKV device pass K and V blocks in a ring topology using altogether computing local attention and accumulating results with the online softmax trick. So the answer again is B. Heidi hypothetical document embedding query augmentation technique for the rack. What is the core hypothesis behind YDE and under what condition does it fail? So it uses LLM to generate a hypothetical answer document from query embeds that document, retrieves by similarity to the hypothetical embedding. It's failed when LLM hallucinated content uses systematically wrong domain terminology, pulling retrieval toward irrelevant documents. So the answer again is B. Then 10th one. The REC system retrieves the top K passages using cosine similarities between these and these pairs and distance A and pair B, then distance this. So the practitioner claims since D, A, D, B have the two positive first component dot product similarity, in this claim correct, and what are the two cosine similarities? So the answer is, the claim is correct. QDA and 1 under root 2, then QDB 1 by 2, 0.5, DA ranks higher. So the answer is A. And this is for all for this week, and I have covered the whole 10 questions. And thank you for watching. Please subscribe my channel and please hit the like button and share with your friends. Also, don't thank you.